So here we are required to determine the average value of power. So what was done here, these values were obtained from an experiment. They got values of power consumed when time was 1 hour. It was a particular value. Then at 2 hours, it was a particular value. At 3 hours, it was at a particular value, up to when we reached 6 hours when power was zero. But then later on, when we used the mid-ordinate evaluation, we obtained the mid-ordinates for power, and for the interval or the sub-interval between 0 and 1, we have 7.0 kilowatts. Between 1 and 2, we have 21.5. Between 2 and 3, we have 42 kilowatts. Between 3 and 4, we have 49.5. 4 and 5, we have 37. And 5 and 6 will have 10.0 kilowatts. So we are supposed to use the mid-ordinate rule to determine the area. So we are to determine the area here, and therefore you remember that according to the mid-ordinate rule, the area is going to be y. Okay, it is going to be h. If we take h as the length of or the width of one sub interval, so this will be h into y1 plus y2 plus y3 up to yn. That is if what is inside here are the values of the function at mid-ordinate values of x. The values of the function at the mid-ordinate values of x, if we are talking about a function f of x. But here, since we are talking about power, then we are going to be talking about y1 being the value of power between, midway between 0 and 1 hours. Y2 is going to be between midway, t is equal to 1 and t is equal to 2 hours, and so on and so forth. So the area, therefore, will be, since the width of each sub-interval is, you can take any. So 6 minus 5 is equal to 1, 1 minus 0 is equal to 1, 3 minus 2 is equal to 1. So it is a constant, and therefore it is equal to 1. So h is equal to 1 into, then y1 is going to be 7.0 plus y2, which is 21.5, plus y3, which is 42, plus 49.5, plus 37, and plus what? Plus 10.0. When I evaluate this area, I'm going to get, so the area is going to be 167 kilowatt hour. Okay, so that will give us the energy that has been consumed, okay, by the load. So now it is giving us the approximate area. So the task is to get the average value of power will equal to area under the curve divided by the length of the base. The length of the base is 6, because we are moving from 0 to 6 hours. Therefore, the P average shall equal to 167 divided by 6. And what do we get? I have 27.83 kilowatts. So the power averagely that is going to be consumed over the 6 hours is going to be 27.83 kilowatts. Another method can also be P average can be the sum of ordinates, that is the mid-ordinates. We are talking about sum of mid-ordinates divided by the number of mid-ordinates. And this is going to work when h is equal to 1. So this is going to be 167 divided by the number of mid-ordinates. The mid-ordinates were 6. Okay, 1, 2, 3, 4, 5, 6. So divided by 6, this also gives us 27.83 kilowatts, and that's all. So that's how we can get the average power, okay, when given such a curve, and they have given you the values of power midway between the different intervals of time. So meaning, for irregular shapes, whether regular or irregular, you still have different ways of approximating the area. So if you can approximate the area, then you can also be having the interval or the length of the base. You'll always be able to evaluate the average value of that function. So this formula is still within the average value of a function f of x still equal to 1 out of the length of the base times the area under the curve. So A to be f of x with respect to x still satisfies this formula, which is the average value or the mean value theorem when we talk about a function f of x.